we are building off of what we learned last time in section 3.4 and 5, which was the shape of the basic sinusoidal functions, sine and cosine. Today, we're not going to necessarily have cute functions. We're going to have more complex looking graphs, and we're going to need to be able to describe what's happening to them, changing them from the basic sine and cosine functions into these transformed ones. So let's review just a little bit. This is a sine curve. The reason I know it's a sine curve is because it starts at 0 and then increases. Sine is a periodic function with an amplitude of 1, contains the point 0, 0, has a period of length 2 pi, and has a midline at 0. That is the basic sine function. Cosine is similar, but instead of starting at 0, 0, where does cosine start? At 0, 1. So what I actually want to do here is I want to draw cosine on top of sine, so that I think it's very interesting when we see the two graphs back to back, and I don't know if we've seen that yet. So I want everybody right now, just in pencil, to put a little dot at 1, and then thinking about the values we have around our unit circle. The horizontal displacement when we're at pi over 2, which is 90 degrees, is 0. The horizontal displacement when we're at pi is -1. The horizontal displacement when we're at 3 pi over 2, which is the downward quadrantial angle, means we're at 0. We're 0 units away from the y-axis. And then we get all the way back to 2 pi, we're back at 1 unit away from the y-axis. So if we take a dashed line this time and start to fill in the dots here, make our cosine function, right? We can see that they're the same shape, but just shifted a little bit, correct? Which makes this really cool but really confusing, because as you'll see today, every sine function can be rewritten as a cosine function, and every cosine function can be rewritten as a sine function. Because they're co-functions with each other, they differ by pi over 2 radians, which is 90 degrees. But before we really get into transforming sines into cosines, let's just talk about how we transform them from the basic parent functions, which we have up top, to maybe more interesting ones. We learned last time that there was something called amplitude, right? What was amplitude? Like the highest high versus the lowest, how high from the midline we get. That all comes from this a value multiplied in the very front of one of the sine or cosine functions. Amplitude. That's why I was using the letter A all last class to describe amplitude. So in either a sine or a cosine function, the number in front of sine and cosine, the words that's multiplied there, that is your amplitude. That is your vertical dilation. Sorry. The next letter that we see in this formula is the B, and it's in the same spot for both sine and cosine. And since it is multiplied, but on the inside, that makes a horizontal dilation. Dilation because we're multiplying, horizontal because it's inside. But in a sinusoidal function, what we're going to think about is that the B value is related to the period. It is not the period of the function, but it helps me determine the period of the function, which is why it's going to be blue, because that's our period function, period color. The next transformation we have is the horizontal translation. Now, horizontally translating something just means we're scooting it from the left to the right along the graph. And our horizontal translation in the terms of sinusoidal functions is going to be called the phase shift. We don't necessarily call it a horizontal translation all the time. We now can call it a phase shift. And that's me talking about shifting the graph from the left to the right. And then last but not least, our vertical translation, which is going to scoot the whole graph up and down. Our vertical translation we learned last time is called the midline, but I'm also going to call it the displacement. So all of our transformation vocabulary from 1.12 that we learned back in the fall has new vocabulary associated with it for transformations of sinusoidal functions, which is nice because you're not learning anything new, you're just applying it to a new function type and giving it a new name. Now, what we can do is give you a little bit more details about how to find each of these things. the amplitude, period, phase shift, and midline. To follow our color code, remember amplitude is pink. The formula for amplitude is simply absolute value of A. Being that we are using absolute value to tell me the amplitude, that means amplitude is never negative. So if the number in front of sine or cosine is a negative number, that is not part of the amplitude. That indicates a reflection over the x-axis, not negative amplitude. Amplitude is never negative. But it would show me a reflection over the x-axis. The formula for the period of the function, because like I said, b is related to the period, it's not exactly the period. The period is found, or b is found by doing 2 pi divided by the period. And what might make this easier, because sometimes I'll give you b and ask you for the period, or give you the period and ask you for b, is we can put this into distance, rate, and time. Does anybody know physics where you use this little triangle? Does this look familiar to anybody?
I only know the volume that's going to be on.
Distance, rate, and time?
I think this is on top.
Yeah, something like that. So we're going to use the same thing. Because 2 pi is in the top of my fraction, 2 pi is going to go up here. And this triangle can help me just very quickly solve this tiny equation. Because let's say I give you that the period is 2. You'd put a period right here, and you'd say b is 2 pi over 2, which 2 over 2 cancels, so it's pi. Or if I tell you that the b value is 5, what is the period? You'd put a 5 right here, and you say the period is 2 pi over 5. So it's a much faster way than having to solve this equation over and over again for you to find either b or the period based on what you were given. Now we need to give a little bit of information about b. B tells me really how many waves occur in 2 pi radian, since it's always a ratio with 2 pi on top. How many waves would occur from 0 to 2 pi of this function? That's what the b value is telling me. Like I said, phase shift is really like a horizontal translation, so it's how much we're moving it from side to side. This one's a little weird because our textbook says that it's a plus c in the formula, but we know based on what we learned in other classes that the phase shift always goes the opposite direction of what you see. So since plus c is in our formula, we're going to say that there's a phase shift by a negative c amount of units, which commentary on that means that if you see a plus sign, that means that the parent function shifted to the left. And if you see a minus sign, that means that the parent function shifted to the right. That's not new information. When we study transformations, we always say minus means right, plus means left for translations on the inside. But again, we're calling it a phase shift this time. So a plus is to the left, the parent function moving to the left. A minus is the parent function moving to a right. So period and phase shift will require a little bit of thinking or work, but amplitude, which is absolute value of A, and midline, which is just literally the D value. There's not even a formula for this. Whatever D is the midline. If it's minus 3, your midline is at negative 3. If it's at 7, your midline is at positive 7. So it makes a lot of sense. Plus moves it up, minus moves it down.
What is that?
That's the word up.
No, is that an A?
You're right. My handwriting is trash. That is supposed to be a D. Does that look better?
Yeah.
Okay. Now, this table technically is titled sine, but since sines and cosines really behave the same way, just at different phase shifts of each other, the same transformations with the same formula yield the same results for cosine as they would do for sine. And like we saw earlier at the top, these additive and multiplicative transformations are the same for both sine and cosine Because the cosine function is a phase shift of the sine function by pi over 2 radian units, which is like saying that we had to shift it pi over 2 radians to the left. Today we're going to be reading graphs and not just determining the things I had you determine last time. We're going to be finding the actual values of A, B, C, and D plugged into these formulas to make the basic sine function look like that. Now, I do want you to notice that for example 1, it tells me that we are using sine. Anytime you're given the type of function you're using, you need to remember what it's supposed to look like. Where does sine start? At 0. So sine starts at a midline and then does what immediately? Increases. Then it would decrease and then increase and decrease. We need to keep that in mind when we see we're working with sine so that we know where this graph is supposed to start. Okay, let's look at our first graph. Tell me some things you notice about this first graph without me giving you anything extra. I'm hearing a lot of things, and some of it is good and some of it is not quite. Let's start at the beginning. Let's find the midline. I find it easiest to start by making sure you know where the midline is. 3. So I'm going to go with purple and a dashed purple line to show me the midline, which means if I know eventually I'm going to find the A, the B, the C, and the D, I know that D is equal to 3, right? Because my midline is at 3. Once we see the midline, some other things start to take shape. What now do you know?
The amplitude.
What is the amplitude? 1 jump, but how much is each jump worth? 3. So my amplitude, no matter where I'm looking at this amplitude, is 3 units. So amplitude is 3. Or the A is 3. Those are the easy ones in my opinion, A and D. We should get those no matter what because we're just looking for the midline and the amplitude. We did that last class, we're good to go. B and C get a little funny. When we're looking at B, we do need to find the period of this function. What is the period of this function? Pi. If it starts here at the middle and goes up, the next time I'm at the midline and goes up is right here, which means my period is pi. Don't write down pi for B because that's not it. Remember, B is found by doing 2 pi over your period.
So it would be 2.
So it would be 2. The B value would be 2. Now the last one, again, the phase shift is a little bit more difficult. We said at the beginning that sine should start at the midline and go up.
Wait, Miss, can you explain B?
There's a formula for B. When we find B, we're doing 2 pi divided by the period. The period of this function is pi, so 2 pi over pi is 2. If we're looking at the phase shift, we're trying to find the first time the graph is where it's supposed to be, meaning we want to find a place where it's at the midline and going up. This is the first time I see it's at the midline and going up, correct? Mm-hmm. What's the x value here? 0. So there is no phase shift in this problem. Our C value would be 0. So we could rewrite the entire function. It would be called 3 sine of 2 times x plus 0, close parentheses, plus 3.
So it would be 3 sine, and then...
I'll re-explain, see? So we are looking for one of the x values where the graph is showing me the beginning spot. This is a beginning spot, right? If it's supposed to be sine, this is a midline that goes up. The x value here is 0. If I wanted a different answer, because I could rewrite this in a different way, where's the next time I have a midline that increases?
At pi.
At pi. I could have also written minus pi as my phase shift.
Why minus pi?
Because which direction do we want to move it?
To the right.
Minus pi. Right is a minus direction.
Oh.
We'll see later. Let's do another question so we can understand.
Stay with me. You're right. It is confusing. You're not wrong. It's confusing. Let's try another. We're still writing a sine function here. Similar to last time, what are some things we notice about this function?
It starts at -1.
It starts at -1, so something weird's going to happen here. We're going to have a phase shift.
Is the midline
Because sine
1?
should start at the middle. What's up?
Is the midline 1?
The midline is 1. Okay, so that's a good point. Let's lay out our letters. We have A, we have B, we have C, we have D. I find it easiest to always start with that midline because it's a visual question. So I can be like, there it is, which means D is 1. Check. What else do we know pretty quickly after that?
It's 2.
2 is A, which is also, what's that vocabulary now?
Amplitude.
Amplitude, very cool. Now we need to figure out the period here so we can find B.
Isn't it just pi?
It's pi again, which is nice. Okay, so if I'm looking, here's a minimum. The next time I'm at a minimum is at pi.
So 2.
Pi over pi, but it would cancel out with these two again.
Correct.
Perfect.
Correct. Now here's the weird one. We want this function to start at a midline that would go up, that increases. Where's the first time you see a midline point that increases right after?
At 1 after pi.
Yeah.
Like this one, right?
Yeah.
You could say this one. You could say this one. Corey, I think this is the one you saw. Either of those answers will work. There are multiple correct answers to this. But if we wanted to use this number, what is this x value right here?
That's negative. Oh, wait. No,
This is 0. This is pi over 2. So what's in between 0 and pi over 2?
I don't know.
What do you mean?
No. Where's that for?
Wait, repeat the question.
We're looking for something between 0 and pi over 2. Because we want something right in the middle of those two things.
No, I don't know.
Not negative. We're still in the positives.
This pi, right? Or pi over
Pi's
pi.
bigger. Pi's all the way over here.
Wait, pi? 2 over pi. Yeah, I don't know.
Let me feed it to you this time and then I'll tell you why. The correct answer here is negative pi over 4.
I thought you just said it was a negative.
Literally just said.
Okay, the answer to C is negative pi over 4. Because the answer to the question I was asking you is pi over 4.
That's,
Oh, it is.
That was a confusing question. My bad. That was a confusing question. So here's why. When we're dealing with fractions, the bigger the denominator, the smaller the number. So if I have pi over 2 and I want to take half of pi over 2,
okay.
sorry, take half of pi over 2, that should be multiplied. And I want to take half of pi over 2, 2 times 2 is 4. So halfway between 0 and pi over 2 is pi over 4. What if I needed to go again? What's halfway between 0 and pi over 4?
Would be
Pi over 8. What's halfway between 0 and pi over 8?
pi over 16.
We get it now, yes?
Yeah.
Oh, okay. So we just have to look for that point. So we're transforming this dot right there, that green dot, back to the y-axis, which means we are moving it to the opposite direction. It had already moved to the right. So we got to move it back. Can we try it again?
Yeah.
Great. However, this question changes a little bit. What's the only difference between example 1 and example 2? It's cosine. Okay, so now we're going to be looking for a different starting position. Where should cosine start?
1 or
At,
0.
let's call it a maximum
Yeah.
and should decrease. I don't want to say 1 because we're going to transform this graph. Our amplitude might be bigger than 1. So we're going to say maximum. On the regular function, 1 is the maximum, which is why you said that. That is correct. Okay, let's try this. Okay, what are some things you notice right away?
It starts at -1.
I see that as well, yes.
The midline is 1.
Midline is 1,
And the amplitude is 2.
2. This is actually the same graph that we had just a second ago. You guys noticed it right away. So we have a midline at 1,
Wouldn't the period be?
amplitude of 2. What was the period again? Pi. Okay, so that gives me a lot of information here. I know then that A was 2, B was 2 pi over pi, which is 2. hold on for C, and D was 1. Now, even though this is the same exact graph, we're going to have a different answer for C because now I'm telling you to write a cosine function. Cosine should start where?
Decreasing.
It should
Maximum.
at a maximum, then decreasing. Where's the first maximum that you see?
3. Oh, pi over 2.
Correct. What's the first x value that you see?
Pi over 2.
Pi over 2, right? Right here? This is the first maximum I see?
Yeah.
I'm going to grab that one, and I'm going to move it backwards, which means this becomes negative pi over 2.
That's easy.
Okay, let's check our work. So I see here that this time we have a midline at -1, that our amplitude is 3 units, that my period is pi, and since I'm writing a cosine function, I'm going to pay attention to this first peak that I see. I could pick any of the highest points, but I'm going to use that one. Sorry. This would mean that A is 3, B is 2 pi over 2, over pi, which is 2. The C value would be negative pi over 4, and the D value would be -1. How did we do?
Amazing.
Horrible. I did it.
Great. But here's what's going to happen, is that I'm not always just going to present to you with graphs. I will. This would be something you would see in a multiple choice section. What's going to happen is that you're going to get a scenario presented to you that you're going to have to understand, develop coordinate points for, then transform these graphs. So you know how we keep bringing back up this like broken clock example? Okay, I've got the broken clock coordinate points there for you. This is a clock that goes all the way around in 30 minutes. We remember this example? Okay. So now what I can have you do is actually answer the FRQ3 Part B question that you would get. When you're doing one of these FRQs, which I will do with you in just a little bit, the Part B question is always going to ask you the following. It's going to say the function h, which is the function we've done here, can be written in the form h of t equal to a times either sine or cosine. B times t plus c plus d. Find the constants of a, b, c, and d. That is what you just did in all of these problems.
So it has to be positive.
So let's highlight our graph the way we just did all of these other problems. The first thing I recommend you doing when we're on to this question of the FRQ is to make sure you know where your y-axis is. Your y-axis occurs when time is 0. When the x value is 0. So I put a little bar right there for me visually so I can see it like it's a graph. Okay, we highlight our midline. What is our midline here? 120. We highlight our amplitude. What was our amplitude here? 8. We look at the period. What is the period of this function? 30. And the only other thing we need is to identify the starting place, the green color. Are we graphing a sine or a cosine here?
Sine.
Should it start at the maximum or a midline?
The midline.
Midline that goes where? Up or down?
Up.
So which one of these points should I highlight? K. Very good. So when we're writing this function, we can say, just like we did before, the a value would be 8. The b value would be 2 pi over 30. What is that reduced to?
It would be 2 pi over
15 top or 15 bottom? 15 on the bottom, so it would be pi over 15. The c value would be negative 22.5. And the d value would be 120. We can transform these sinusoidal functions that we learned about last class.
This is the easiest thing to use.
Great. I'm glad this feels a little easy because I'm going to make it a little harder. Everybody get your CYU packet out. We're going to do one of the 4 FRQ3s that I've given you for homework together before you have to do the rest on your own. You're welcome. We're doing a quarter of your homework right now. We're going to not do number 1. We're going to do number 2. So open your CYUs, go to question number 2. This is what FRQ3 would look like. It's going to present to you a scenario. It's a very local scenario for us, right?
Yeah.
We've been all up into the state fair. We've seen the Texas Star. And we're going to work through what every FRQ3 would look like. On the AP test, you have 4 FRQs. They are 6 points each, which means of the 24 points you can get, these are the 6 points we should get. Because we're going to go from start to finish to get the scenario you just said was pretty easy. We're going to get all 6 points. Okay, let's get started. I like to do these now when you're taking your AP test. It is on a computer, so you can't highlight as you go. But right now while we're learning, we're going to highlight as we go. It says, the Texas Star Ferris wheel at the Texas State Fair in Dallas, Texas is enjoyed by fairgoers each year during the month-long fair season. Point B is located at the highest point of the ride, rotates in a clockwise direction, and completes 1 revolution every 82 seconds. When you see something about time, you're going to highlight it blue, because the time is going to give me information about the period of this function. Point B is directly above the center of the Texas Star at time t equals 0 seconds, as indicated in the figure. The diameter of the Texas Star measures 212 feet. Interesting. What is a diameter? Like the widest it goes? Okay, so it would be like all of this, right? Do we want all of this when we're doing these sorts of problems?
No.
No, we just like want this much, right? So if the whole thing is 212, how much is just this? 106. So the diameter of this circle gave me that this amount is 106 feet. That's what that's pink. It also says the ride has a 4-foot clearance between the ground and the bottom of the wheel. That's right here. Because you don't want to scuff your feet on the ground when you're riding the Ferris wheel. Am I right? So we got 4 feet right here. That's just going to be regular markings. We're going to do this. We're going to say 4 feet. As this Texas Star rotates at a constant speed, the distance between B and the ground periodically decreases, then increases, decreases, then increases, decreases, then increases. The periodic function h models the distance between point B and the ground in feet as a function of time t in seconds. Here's what part 1 of the FRQ will always look like. It's going to have you do the wave. It's going to have you give me the 5 points for F, G, J, K, and P. Okay. Let's start with the obvious stuff. Let's talk about the height. How low does this Ferris wheel go?
Like 4 feet.
4 feet. So that means the lowest value here is going to be 4. The lowest value is 4. And then we get the Ferris wheel. How high is the Ferris wheel going to go up at the top?
212. All the way. 216.
106.
I heard somebody say it. It's 216.
What?
Where are they getting the 216 from?
All of the 212 plus the 4 feet.
Correct. You have the diameter, the 212 diameter, plus the 4-foot clearance. So 212 plus the 16.
So would the middle one be 106?
That's a great question. What would the middle be?
110.
It would be 110.
Bro,
Why would it be 110? Let's talk about it.
because you subtract a little. Wait.
It's because we have the 106 as the amplitude, but then we still have our 4-foot clearance, so we still got to go up 4 more feet. We've got all of these points. If you can get the output values here, the heights, correct, that is your first point on this FRQ. The outputs and the inputs are separated points-wise. So if we can understand this problem to see how high, how low, and how middle, whatever your question is talking about, you get a point. Yay. Now let's do the period. It says point B is directly above the center of the Texas Star at time 0 seconds. So where should I put 0 on here? F, because it should be up high, right? Time 0 is right here. Okay, cool. It says that it makes 1 complete revolution every 82 seconds.
Was P be 82?
So P's X value or T value is 82. Very good. Now here comes all of this arithmetic in our head. If this is 0 and this is 82, what's this one? 41, because it's half the distance. Very good. If this is 41 and this is 0, what's this? 20.5. Here's the hard one. If this is 41 and this is 82, what's this one? 61.5. Very good. If you can get the times right, that's your second point on this FRQ. From just with one part A, you get a point from the X values and a point from the outputs, from the T values and the H of T values. Do we feel like we can do that?
Yes.
Okay, cool. To help us annotate this, because we're learning, let's go ahead and add all of our colors to this graph so we can make the next one easy. You obviously wouldn't do this on the AP test because you don't get highlighters, and like this is coming from a computer and all that business. So we have this, we make sure our period is correct, 82, check, and then we pause on the green color because we need to read the next part to know what type of function I'm writing here.
I'm guessing the rest of the 4 points are that.
It's just 2 more points. The function can be written in the form a times sine.
So that can be positive.
So what are we looking for as our starting point?
Midline.
A midline that goes where? Down or up?
Increases, so it'll be K.
So it would be K. This is what we would get our next 2 points from. If you can give me the vertical transformations, which are A and D, that's a point. What's our midline here?
I don't know, because
110.
110.
amplitude would be 4.
So the amplitude would be
216.
116.
Oh, it would be from. Oh. Because you would subtract 1.
Yeah, 110 is our middle line. If our highest we get up there is 216, 216 minus the midline is 106. Let me give you the colors back because I'm using the wrong colors. I'm using no colors. This was 106. This is 110. The B value and the C value together give you your fourth point in this FRQ. Now, the reader would be looking for a final answer here. So you know how we've been doing like 2 pi divided by something and then getting a final answer? I prefer, as the reader who reads these things, you to do your work for B off to the side. We're going to do this time 2 pi divided by something. What should we be?
61.5.
Well, remember, we're looking for the period. What is the full period of this function? I heard someone say it, I think. 82. That's how long it takes for me to finish an entire revolution around the Ferris wheel.
So pi over 41.
So pi over 41, because if we reduce this, it's dividing by 2. So this is pi over 41. But then you guys have already noticed where this sine function should start, which is at the k value. So we can do negative 61.5 as my k value.
How come it's a toner?
Now, your last 2 points from this FRQ come from your favorite questions that you're ever asked. Refer to the graph of H in part A. The t coordinate of F is T1 and the t coordinate of G is T2.
Negative and decreasing.
So we're looking at this section between F and G. We're looking at this section right here. Looking at the output values is where we're looking for part 1. On the interval from T1 to T2, which is true about the output values? Are those output values positive or negative?
I think it's negative. It's concave down. But,
Ooh, output values.
oh. Concave up, so it's positive. and
Output values.
What?
It's decreasing.
Are my output values positive or negative?
Oh, positive.
Positive, but are they getting bigger or getting smaller?
Smaller.
So this one we would say this is positive and decreasing. What you're thinking of is answering the second question, which asks you to describe the concavity of the graph and to describe the rate of change of the graph. So then we would write the sentence that answers that question. We would say the graph of H is what? Concave up or concave down? Concave down. And the rate of change of h is what? Decreasing. That's perfect.